Hello Year 7, welcome to today's lesson. Let's start by doing the solution to the puzzle from last lesson. So the question you were asked last lesson is there a limited or an unlimited amount of prime numbers? And the answer is there's an unlimited amount of prime numbers. We're never going to run out, there'll always be more prime numbers. But I asked you to show why that is. So let me show you here the reason for it. What we're going to do is something called a proof by contradiction. So what we do is we say, well, let's just say there is a limited number of prime numbers and we are going to run out, okay? So we assume there is a limited amount of prime numbers, and let's just say the number of prime numbers is n. N could be very high, but it's still a finite or limited number. Then what I'm going to do is I'm going to multiply all my prime numbers together. So there's n different prime numbers here, and I'm just going to write there's n numbers here, and I'm going to go here are all the prime numbers multiplied together, 2 by 3 by 5 by all of the prime numbers up to the very last one, if there was a very last one. Then what I'm going to do is I'm going to add 1 to it. So I look at this big number I've made, where this is the product of all the prime numbers, so every single prime number is a factor. Then I add 1 to it. Well, hang on, 2 is a factor of this, so I add 1 to it, so it can't be an even number, it can't be divisible by 2, must be an odd number. But this whole big new number, which is all the prime numbers multiplied together, 3 is a factor, and I have to add 3 to get to another multiple of 3, so 3 can't be a factor. Well, 5 can't be a factor of this if I've added 1 to it, because this number must now either end with a 1 or a 6. So this huge number I've made by multiplying all the prime numbers and then adding 1, it must be another prime number itself. So in fact, there are an unlimited amount of prime numbers, because if there were a limited amount, I could always just multiply them all together and add 1. Let's take a look. So 2 plus 1 equals to 3. 2 times 3 plus 1 equals to 7. 2 times 3 times 5 plus 1 equals to 31. And you see that I'm generating new prime numbers every time here. Notice I don't get every single prime number, like I've missed, for example, 5, 11, 29. I've missed a lot of prime numbers, but I can always make a new prime number by doing this, so there's an unlimited amount of prime numbers. Okay, on with today's theory, which is index laws. My first index law is if I get two numbers with the same base, and the base here is 5, I've written it as base x, and I times them together, I add the two indices. And let me show you what that looks like. I'm going 5 cubed times 5 to the power of 4, and that's going to equal to 5 to the power of 7, not 5 to the power of 12, which some people might be tempted to say. The reason is I go, okay, 5 cubed is 5 times 5 times 5, and 5 times 4 is 5 times 5 times 5 times 5, and if I multiply them all together, well, it's just 7 5s multiplied together, as you can see here, so that's just 5 to the 7. Alright, the second index law. If I divide two numbers with the same base, so I've got 2 to the 7 divided by 2 cubed, I subtract the powers, and there it is, 7 minus 3 is 4. And let's see why that is. So I go, okay, well, 2 to the power of 7 up the top by 2 cubed down here, and what I can do is I can just start cancelling. So I can just go, well, I'm going to cancel this with this, right? So I've got this down the bottom is just 8, and this part up the top is just 8. So I'm simplifying the fraction by dividing them both by 8, and that just leaves me with 2 to the power of 4 up the top. And you can see it two ways. So there it is, 2 to the power of 4, 2 times 2 times 2 times 2 is 2 to the power of 4. Or if you want to see the numbers worked out, 128 over 8, and I simplify this fraction by dividing the top and bottom by 8. 128 over 8 is 16, but 16 is just 2 to the power of 4. Okay, our next rule. If I've got something like this, a power to a power, I times the powers, okay? So x to the m all to the power of n equals to x to the mn. And let's have a look. 5 squared to the power of 3. Well, that's just like getting 5 squared and timesing it by itself 3 times. So 5 squared times 5 squared times 5 squared. But that's just 5 times 5 times 5 times 5 times 5 times 5 times 5. So that's 5 to the 6 timesing the powers together. Notice that if I swap the two powers around, it's the same. Here's 5 cubed all squared. 5 cubed times by 5 squared, but that's just 6 5's all been times together as well. Hence we get 5 to the power of 6. Okay, let's look at our next index law. And if I have anything to the power of 0, it's always equal to 1. I've done it with 2 to the power of 0, but you could pick any number other than 2. So I go first of all 2 to the power of 3 divided by 2 to the power of 3. I remember my rule from before, which is I go anything here, 2 to the power of 3 divided by 2 to the power of 3. I'd minus the indices, so I go, well, okay, where is it? Here it is. 3 to the power of 3. Well, that's just 0, so I know this is 2 to the power of 0. But 2 to the power of 3 divided by 2 to the power of 3, it's just 8 divided by 8, which is 1. So this and this must be the same, so we know that 2 to the power of 0 is just 1. Alright, let's try an example. Here's our example here. I want you to pause the video and actually have a go at working it out. So pause the video now and do it. Okay, so I assume you've paused the video now and you've worked it out. So let's check our answers. We've got 2 cubed times 3 squared. I times these two powers by 5 and I've got 2 to the power of 3 to the power of 5 is 2 to the 15. And 3 to the 10, timesing those indices. Note I'm not actually going to try to combine these, okay, because I've got different bases, a 2 and a 3, and different powers. So now I'm going to, I'll do the same for the bottom, of course, 2 to the 12, 3 to the 16 for the same reason. Now I'm going to cancel things down. So 15 minus 12 is 2 to the 3 up the top, and here I've got 3 to the 10 up the top and 3 to the 16 down the bottom, and that's going to be just 3 to the power of 6 down the bottom. And this could also give you a bit of an idea of, I'm just going to ask you an extra bonus question here. What do you think 3 to the power of 10 divided by 3 to the power of 16, using our index laws, we know that's going to be 3 to the power of 10 minus 16 is 3 to the power of minus 6. But I wonder what 3 to the power of minus 6 actually equals to. I might do the answer for that one next time too, or you can tell me in the comments on the Google Classroom. Okay, time for our puzzle. So our puzzle is, we've got some very funny looking indices here. They're fractions. So the first one is, what is 16 to the power of a half? I can't times 16 by itself half a time. What about 1,000 to the power of a third, or 64 to the power of 2/3? So I'll do the answers for these next lesson. Alright, time to look at our homework. Our homework is 11F. I think the homework sheet says 11E, but that's a typo. We mean 11F from Cambridge 7, and you're going to do questions 1 to question 14. Okay guys, thanks very much. Don't forget to watch this during your, well, you've already watched it, but make sure you mark your roll or mark your name off on the roll doing your Year 7 classes on your timetables, and submit your homework to your class teacher.